Alright, so students were supposed to look at question number 6, and they were given 7 problems, and I labeled them. Go ahead and label them in your papers. 1, 2, 3, 4, 5, 6, 7. And then what you're supposed to do with those 7 is you're supposed to sort each expression based on whether it can be factored over the set of real numbers or over the set of imaginary. So if you basically have an I in yours, yours is going to be imaginary, and if you don't have an I, then it's going to be real factors. And so that's what the students were asked to do for those set of problems. You were asked to factor and solve. Class, can we factor it? Are there 2 numbers that multiply to be 4 but add to be 0? We would say it is a prime factor, which means that you cannot solve this by factoring. You're going to have to use a quadratic formula. The quadratic formula, although it's very short or long? It's very long, it will always work. Oscar, tell us the quadratic formula.
So wait. If x equals negative b plus or minus the square root and b squared minus 4ac.
Okay, this was a common mistake last class. I saw multiple students. Sounds kind of weird. Draw a long fraction line. A long fraction line. That b there doesn't exist. And what you're going to do is you're just going to substitute in your values. So if b is equal to 0, that means every b value in here, you're going to write 0. And every a value, you're going to write a 1. And every c value, you're going to write 4. Let's do that substitution. Remember, you have to have that minus sign there. Remember, you're always doing the color substitutions with a parentheses. So my b value is 0. I have plus or minus. I have the square root. My b value is 0. I have minus 4. My a value is 1. That's what I'm putting in there in pink. And my c value is 4. All over 2 times 1. So I wrote down the formula, I did the substitutions, now I'm going to simplify. A common mistake for students is to try to do all of those all at once. And because this formula is so long, there is often mistakes. Now I want you to think about the number line. What's the opposite of 0? Well, 0 is neither positive nor negative. So you don't tell people you are 0 plus 16 years old. You normally just tell people you're 16 years old. So you don't have to write this part. It's gone. I have plus or minus. Class 0 squared. Negative 4 times 1. And negative 4 times 4. Negative 16. All over 2. So I now have plus or minus. 0 minus 16 is negative 16. And here, this is what I'm going to do with the negative square root. I'm going to put that as negative 1, square root of negative 1 times the square root of negative 6, or positive 16, all over 2. Class, what do we know about the square root of negative 1? It is I. So in that location, plus or minus I times The square root of 16? 4 all over 2. And I have x equals plus or minus. The I is going to be there. Class, what's 4 divided by 2? Yeah, it's just going to be 2i. So this is what it would mean to solve. When you solve for x or solve for a variable, it just says x equals. Now remember, this is actually two solutions. You have a positive 2i and a negative 2i. And to launch into today's lesson, if I said this, in the beginning you said, Mr. Ng, I could not factor. I could not factor to solve this. Well, after I show you this, you actually can factor. You wouldn't use the x method, you would have to use the quadratic formula. And you would always write your answers as x minus. Everyone say x minus. X minus. And then I'm going to put in my two answers. Positive 2i. There in red it's positive, right? You don't need two math operations. And then this one is negative 2i. So this would simplify to be x minus 2i, x plus 2i is your answer. So can we actually factor? We can. It's an indirect way. You're not using the x method like we traditionally have done. You're using quadratic formula, and then you're putting your answers into x minus, x minus. These are called factors or binomials, and then this is your answer. You've actually now factored over the complex number system. Alright, Alex, which one do you want us to help us with? Factoring or quadratic formula? What is the quadratic formula?
Negative b plus minus.
Negative b plus minus square root
b squared minus 4ac, then all divided by 2.
Thank you. Alex, what is your b value?
The b value is 0.
Good. This is a common mistake for students. Your a is 1, your b is 0, your c is negative 4. Keep going.
A is 1.
B.
So that's 0 squared minus 4 times 4 times negative and divided by 2 times 1.
Good. Thank you, Alex. Camille, let's simplify this. Opposite of 0. And we don't have to even write 0, right? So I have plus or minus. 0 squared?
0.
Negative 4 times 1?
4. Oh, negative 4.
And negative 4 times negative 4?
16.
16. Positive 16 over 2. Camille, 0 plus 16?
16.
And square root of 16?
4.
4. Thank you. Lizeth, what's positive 4 divided by 2?
2.
And what is a negative 4 divided by 2? Negative 2. So we have two solutions there. Notice I did the plus and minus and the division at the very end. Okay? Help us with factoring. Angel R. Let's try it. Angel R, what is A times C? correct? B value? And Angel, two numbers that multiply to be -4 but add to be 0. Good. So if I do these. Okay, so yesterday we learned to put these in here. Now, you might be asking, when do I kind of do that minus parentheses? Even if you did the minus parentheses part, watch. You guys know what I'm talking about? When they were longer problems?
Mm-hmm.
And if you put in the -2 and then the 2, this becomes what? X plus 2, and that becomes x minus 2. And then you would just set each of those equal to 0, and you get the same thing, right? That becomes what? -2 and a positive 2. So the big idea I was trying to show you is that you can solve this quadratics either by factoring or using the quadratic formula. If factoring by X box method does not work, you can find your answers, and you can still plug them in to actually get your factors. That's a big idea. Okay, and if you graphed it, you would start at a -4. That's your y-intercept, and then you would have 2 and -2. A value is positive; it's pointing up, and it's an even degree polynomial. Class, can you factor this? A times C is 5, B value is 2, no two numbers multiply to be 5, but add to be 2. So now we have to use the quadratic formula. Leslie L., tell us the quadratic formula. All over. Make sure your fraction line is very big. I saw a couple students get stuck because the fraction line is small. Remember, guys, when you're getting your bathroom passes, the blue paper. Whoever's next on the blue paper. Let me color code this for you. My A value is 1, my B value is 2, and my C value is 5. So every A value I'm going to put in is 1. Every B value I'm going to put in is 2. And every C value is 5. Ariana, do the substitutions for us. What is your B value?
2.
A value?
1.
C value? And our A value? 1. Let's go ahead and simplify this. Leslie P. Opposite of -2? Echo? Sorry, opposite of a +2? Yeah, let me say it again. Opposite of a +2? 2 squared. -4 times 1. And -4 times 5. -20. And 2 times 1. Partner B, tell partner A, what did we learn about I? Nathan, what did we learn about I? Feel free to look on the board. Alright, so I meant to break this up into 3 factors, or 3 radical signs. 1, 2, and 3. These are all by multiplication. So negative 1 times 4 times 5 gives us the... should have been negative 16. Why did I do that? Let's do this as a 4. All over 2. So now I have negative 2 plus or minus. Partner B whisper to partner A, what do you know about square root of negative 1? Darlene, what do you know about square root of negative 1? So we're going to write I here. Square root of 16 is really just 4. Okay, this is... let's just make that square root of 16. Now, notice what I would do with this 4 here. Again, I've seen this a couple times today. Students write square root of 16 is the square root of 4. The answer is no. 2 identical numbers that multiply to be 16 is 4. This 4 here has no radical sign. All over 2. Now what we're going to do is we're going to take out a GCF. Everyone say GCF? Let's pull it out. What do you think that is? 2. So I have 2 times what? Negative 1 plus or minus. What am I going to put here? 2. Because 2 times negative 1 is negative 2. 2 times something equals I4, or 4I. This will be a I there. All over 2 times 1. So now I have x equals negative 1 plus or minus 2i. What's happening here is that these 2's are canceling, and you're left with this answer in red. Now, this is the time to split your plus or minus. X equals negative 1 plus, so just take your finger, cover up one of the math operations, so you have plus 2i, and negative 1 minus 2i. So the red box is essentially 2 solutions, and there are your 2 solutions. I know that was long, but it gets better. There's more. Got it down? Okay, question. Does my solution have any imaginaries in it? Yes or no? Does it have an I in it? Yeah, so our solution has an imaginary in this. So, in today's activity, if you go over to page 13, we just did this one here. And so, I would put x squared plus 2x plus 5 and I'm trying to use these colors to really point out what's happening here. So this is the problem we just did, x squared plus 2x plus 5. I put it under the imaginary factors because there's an I in it. So now I'm going to copy my answer here in red. These 2 right here, I'm going to write 1, 2. 1, 2. So let me do that. Negative 1 plus 2i, and negative 1 minus 2i. I'll give you time to copy both of them, but just let me summarize the big idea. We were supposed to factor and solve. And you're asking, how do I get those binomials as my answers? Well, we couldn't factor by using the X box method, but we can essentially in some ways factor or get the factors by using the quadratic formula. And we have the square root of negative 1 is I. These solutions must go where it says x minus, and you just put your answer there. So now we have the factors. So maybe a long time ago in Algebra 1, you say I couldn't factor this. You would have no real solutions, but now we have these complex solutions. They have I in them. For question number 4, you have x squared plus 4x minus 5. We're going to see if we can first factor that. So let's do that together. I'm going to rewrite the problem. X squared plus 4x minus 5. In front is my a value, which is a 1. My b value is 4, and my c value is negative 5. So let's see if we can factor this. In x method of factoring, you have a times c and your b value. So 1 times negative 5 is negative 5, and your b value is 4. Okay, so now we have to list out all the numbers. Numbers that multiply, their products are 5, and they add to 4. Well, if you look at that number, I'm going to choose 5 and a negative 1, because 5 times negative 1 gives you negative 5, and 5 plus negative 1 gives you 4. What does that tell me? This can be factored. So I'm just going to put in here plus 5 and minus 1. So this is my answer factored. So if I had to say what do we do in this first part right here, we just did factor. The next part I'm going to do is solve it. Let's solve it. So now what I do is I'm going to set this equal to 0. And what it's doing basically is you have anything that's going to cross the x-axis. This is just a visual negative 5, and your graph's going to look something like that. But anyways, if it crosses the x-axis, then these x-intercepts, these zeros, have some kind of coordinates, and the coordinate I already know is going to be negative 5, 0. So your y value is 0, and your x value is some kind of number. So that means one of these has to be equal to 0. So x plus 5 equals 0, x minus 1 equals 0. Subtract 5, add 1. X equals negative 5, and x equals 1. So then the third thing, which we already just did right there, is that you get to graph it. So if you graph this, let's use color coded. I got x equals negative 5. 1, 2, 3, 4, 5 right there. And then x equals 1. And then, one bonus one is negative 5. Your c value is your y-intercept. 1, 2, 3, 4, 5. And then there's a couple other things we learned previously, is that if you find the midpoint between these 2 points, so this is 5, that's 6, so 3 right here. So let me say again how I did that. Negative 5 plus 1 is negative 4, and negative 4 divided by 2 is negative 2. If I put an axis of symmetry, or line of symmetry, basically it folds it. You see it? 3 and then 3. So that basically means my graph's going to go somewhere in there. And we're just estimating. We're not super accurate graph. And it's going to go through that y-intercept. So I know that it's not going to be exact, but this is not the minimum, and this one is, okay? So that's how we did this problem. Let's take a look at the quadratic formula. So the first thing I'm going to do is always write down the quadratic formula. X equals negative b plus or minus square root of b squared minus 4ac all over 2 times a. And what I'm going to do there is just substitute in my values. My a value is 1. So 1's going to go there and there. My b value is 4. So every b value, I'm going to put in 4. And every c value is going to be negative 5. Now, as I do my substitutions, which I'm doing in this step, I'm going to put them in parentheses. So a negative sign, my b value is 4. 4 squared minus 4 times my a value, which is 1, c value, which is negative 5, all over 2 times my a value, which is 1. X equals negative 4 plus or minus 16. Negative 4 times 1 is negative 4. Negative 4 times negative 5 is plus 20. And then I'm just going to go ahead and just simplify it. X equals negative 4 plus or minus the square root of 36 over 2. Make sure you make that division sign long. And then 2 identical numbers that multiply to be 36 are 6. Right? So make sure you're not having a radical sign. That's another common mistake. Put a 2. And really what this is just 2 problems. You have x equals negative 4 plus 6 over 2. So now I'm separating this plus or minus. X equals negative 4 minus 6 over 2. So you can the plus sign and then the minus sign. You get 2 divided by 2, which is 1, and then negative 10 divided by 2 is negative 5. And you'll actually notice that actually matches my solutions over here. And you'll notice that I don't have any i's in here. So if there was an I, imaginary number, which basically means you have a negative square root, it would have been there. But we don't have that. So if your answer sheet, that one goes here on the real side. So those are my factors. I have negative x squared plus x plus 12. And some of you actually just jumped to quadratic formula. You will always get the answer for the quadratic formula. When, class? Always. Okay? But factoring actually is the fastest if it works. So let's try it. I'm going to factor out a negative 1. It's going to change all of my signs, so I get x squared minus x minus 12. And then I'm going to see if I can factor this. Now this one doesn't really work too well with the Xbox method, but the one inside the parentheses does. Inside the parentheses I have a times c, which is negative 12. B value is negative 1. My 2 numbers that multiply to be negative 12 are 4 and 3, but they must add to be negative 1, so this will be a minus 4. And this would be my answer in factored form. Now, if you chose to use the quadratic formula, you would have just set each of these equal to 0. Negative 1 is equal to 0. X minus 4 equals 0. X plus 3 equals 0. This is a no solution. X equals 4 and x equals negative 3. So, again, if you did the quadratic formula or factoring, you'll get the same 2 solutions. But I just wanted to show you if you take out GCF from negative 1, it's possible still to factor that one. Alright, so we're supposed to solve this by the quadratic formula. Darlene, can you tell us what the quadratic formula is? What math symbols? Keep going.
The square root. And then b squared minus 4 ac over 2a.
So make sure you write a big division sign, and there's a quadratic formula. Thank you, Darlene. Peter, can you help us identify the a value? So a is -1. Peter, what is your b value? +1. Can't use yellow again, Mr. And your c value? C is 12. Thank you, Peter. Roberto, do the substitution. Roberto, what is your b value? So 1 squared. A value is -1. What's your c value? And your 2 times -1. Let's go ahead and simplify this. Marco, what's the opposite of -1?
Positive 1.
Sorry, say that again. Opposite of +1.
-1.
1 squared?
-1 squared?
So it just means 1 times 1?
Yeah. Oh.
Marco, -4 times -1?
Positive 4.
And +4 times 12?
48.
So that's a positive over -2. Casimiro? 1 plus 48?
48.
Partner A, tell partner B 2 identical numbers that multiply to be 49. Ashley, those 2 numbers? Yep. This was a common mistake, so I want to point out. Yesterday, I saw a lot of students say square root of 49 equals the square root of 7. That would be incorrect. The conceptual behind that is you have a big square made up of little squares, and there are 49 little squares. The question, what are those 2 identical numbers? You guys told me was 7 and 7. Okay, that's why you can say 7 squared equals 49. So the square root, or going the opposite, is 7. Notice there's no square root there. Alright, Lana, let's now separate the plus and minus. Lana, what's -1 plus 7? And 6 divided by -2. -3. And then Lana, what is -1 minus 7? Positive or negative? Negative, so -8. And what's -8 divided by -2? Okay, so we factored and we did a solving. Okay, now one big idea from the past couple of days is to be able to write our factors. Okay, what does that mean? If you had to go backwards, which we have seen, to write factors, you write x minus, like this in green. And then you have to put your answer in red. It sounds kind of redundant for an easier problem like this one. So if I just put in -3 and +4, then my factors are x plus 3, x minus 4. Now, if you factored it, which we did yesterday, if we graph this, let's graph it. We know that it goes through -3. Zoom in for you. -3 and +4. So I have -3 in green, +4 in pink, and then my C value is my y-intercept. Uh-oh. How do you draw a parabola through that? The parabola is facing which direction? Down. You see, without this point, you just knew that it was a parabola. It didn't matter up or down. But we knew that A value is negative, so I know it's going to point down. And then my C value is my y-intercept. So your graph's probably going to look something like this. So this is a review, and actually you're going to do this today again. You're going to factor. And you can use the quadratic formula in some ways actually to factor. Solving it. Solving means getting it, setting it equal to 0, or basically your answer is going to be x equals, and then you can make a sketch. For question number 6, we've been working on, can you factor this? And the answer is going to be no. You can't factor it. A times C is -1. Your B value is 4. There are no two numbers that multiply to be -1 and add to be 4. So you're going to have to use the quadratic formula. Tell us the quadratic formula. Marco.
B plus or minus.
Start again. X equals.
X equals -B plus or minus square root of B to the power of 2 minus 4A times C over 2 times C.
Okay, so always write down the quadratic formula. Don't even touch it. Okay? Alright, next thing I'm going to do is I'm going to do my substitutions. Cynthia, what is your B value? So there's my A, B, and C. Notice how when I do a substitution, I'm using parentheses. So B is 4. I'm putting it inside the parentheses. Cynthia, your A value? Remember, there's a number in front. The A, B's, and C's are just coefficients or numbers. They never are variables. And Cynthia, your C value? And your A value? 1. So A is 1. Thank you. And then we're going to simplify. Nancy, what's the opposite of 4? Nancy, 4 squared. Nancy, -4 times 1 times -1. -4 times 1. And -4 times -1. Yeah. So it'll be 4. And then 2 times 1? 2. And then Chris, the square root of 16 plus 4. What is 16 plus 4?
20.
Chris, what are the factors of 20? Say 2 and 10?
2 and 10.
Anything else?
5 and 4.
Oh, 5 and 4. Oh. We're almost there. Uh-oh. Did I make a mistake? We're okay? Let's just keep going. We're on a roll. Brian, can you simplify the square root of 5?
No.
How about the square root of 4?
Yeah.
What is it? Yep. The square root, if I had to define it to you, is, let's do it the easy one, 2 identical numbers that multiply to be 4. There, Brian said the answer is 2, right? That's why they call it the square root, or 2 squared, right? Because it's area. Okay, I'm going to do a short little pause. Partner B, tell partner A, what is the greatest common factor on the top and the bottom? Ready, set, go. Class, show me with your fingers. Okay? So if it's a 2, they're both even, so pay attention. I'm looking at just this number and this number, not the radical sign. Treat the radical sign almost like a variable like x. Okay? Okay, what's left? Class, tell me. -2. Plus or minus. Radical 5. All over the factors of 2 is 2 a prime number, class, yes or no? So that means the 2 numbers that multiply to be 2 are 2 and 1. So I cancel out my 2's. I'm left with x equals -2 plus or minus radical 5. Partner A, tell partner B, what are the 2 solutions? How do you break that apart?
You can divide the -2 by radical 5, or you can factor it out.
JP, tell us the 2 solutions. Okay, this is where we're basically splitting apart the plus and minus sign. Does that help or no? Do you need more hints?
Yeah.
Okay, I'm going to use my finger, okay?
Plus.
So read it to me.
So -2 plus radical 5. And -2 minus radical 5.
Okay, let's place this somewhere now. I know it's a long problem, we're almost there. Is that not the longest problem of your life? Okay, question. Yes or no? Do you see an I in there? Do you see imaginary numbers? So it's not going to be an imaginary factor, it's going to be a real factor. So I'm going to write the original problem. X squared plus 4x minus 1. Do the best I can to fit it all in here, okay? I think we started to do this at the end of last semester. You need to write factors. In order to write factors, you're going to write it with x minus. Everyone say that.
X minus.
What are you going to write over here?
X minus.
X minus. And then the crazy thing is, we're going to do a substitution. So I need to put in, write super small. We're going to write each of our solutions, one of our solutions, into one of those. So this would be negative 2 plus radical 5 and negative 2 minus radical 5. So I'm going to zoom in right there. And then you can always clean that up by distributing the negative sign. But the big idea is that we use quadratic formula. We know it's under the real factors because our answer had no I in it. There was no negative in the square root. And then the very end, you just write x minus, and then put your substitution in parentheses there. Alright, so for question number 7, you could try to factor this, and some of you guys got stuck in trying to factor, because a couple of problems actually do work by factoring. If I factor out a negative 1, I get x squared minus 6x plus 25. And then I'm going to take my a times c. That would be 25. And my b value, negative 6. Can you guys think of two numbers that multiply to be 25 and add to be negative 6? No numbers. So you can't solve this by factoring. You can solve this by quadratic formula. Now, if I'm using the quadratic formula, I'm going to use a equals negative 1, b equals 6, and c equals negative 25. Let's do the substitutions. My b value is 6. My b value is 6 squared. My a value is negative 1. And my c value is negative 25. All over 2 times negative 1. And now I'm going to do the opposite of 6, which is negative 6, plus or minus 6 squared. Class, is that 12?
No.
Yeah, that's a common mistake. Remember, it's 6 times 6, which is 36. Negative 4 times 1 is positive 4, and positive 4 times negative 25 is negative 100. All over negative 2. Guys got that far?
Made it there.
Then I have x equals negative 6 plus or minus the square root of, that becomes what?
Negative 64.
Negative 64 over negative 2. Then I have x equals negative 6 plus or minus the square root of negative 1 times the square root of 64. All over negative 2. So now I have negative 6 plus or minus the square root of negative 1, class, is I, and the square root of 64 is 8. Now they normally like to write the 8 first. It's, again, treat I like a variable like x, so they would like 8i over negative 2. Okay, some students ask about what happens to this negative sign. Now, notice how I haven't touched that plus or minus to the very end. So let's just try splitting them now and see how we can simplify this. Negative 6 plus 8i over negative 2, and negative 6 minus 8i over negative 2. If I work on this left side, the negative 2 is actually to each of these terms. So you're going to have class negative 6 divided by negative 2, and 8 divided by negative 2. So that gives you negative 4i. And then over here, 3 and plus 4i. Does that help? So now we're almost there. For number 7, let's make sure we know how to do this all together. Class, is that going to be a real or imaginary?
Imaginary.
It's going to be imaginary because I have the letter I. So let's write our answer. Negative x squared plus 6x minus 25. Let's make this super obvious. X minus. And my solution, I'm going to put it inside the parentheses. Zoom in as much as I can. So here I have 3 minus 4i, 3 plus 4i. And then if you actually wanted a complete answer, you would do something like this. You would distribute the negative sign, and you would get minus 3 plus 4i, and then again distribute the negative if you wanted to, minus 3 minus 4i. So either in the blue or the purple here, these would be your imaginary factors. So we couldn't use the X puzzle or X box method of factoring to find my factors. We had to use the quadratic formula. We have imaginaries, and so now we put that underneath our imaginary factors.